Hey everyone, Morgan here. Page 5 of the honors outline dealing with acids and bases, and it's going to be a very mathematical day today. Let's talk about an acid. We know that the pH of an acid is always going to be less than 7. The pH of a base is always going to be greater than 7. Now that's as long as we're at 25 degrees Celsius, which is where we always do these things, so I wouldn't worry about that too much. Okay, now the other thing that we know based on this is that the concentration of H3O plus will always be greater than the concentration of OH minus for an acid. And the concentration of H3O plus will always be less than that of hydroxide for a base. Now mathematically, if this is 25 degrees Celsius, the concentration of the H3O plus is going to be greater than 1.00 times 10 to the negative 7th, and the concentration of hydroxide for a base will be greater than 1.00 times 10 to the negative 7th. Okay? Now, we're going to need to rely upon an idea from Algebra 2 called logarithms to be able to deal with these numbers. You've probably seen this before, but just as a quick little review, the log base 10 of a number A is equal to B, such that 10 to the B is equal to A. That's your basic definition of logarithms. Now, we are not going to deal with natural logarithms. These are the common logarithm or the base 10 logarithm. And there are two properties of logs that are very useful to us. The log of a product, the log of AB, is equal to the log of A plus the log of B. And the log of a quotient, A divided by B, is equal to the log of A minus the log of B. Now you're not going to have to do this very often. The calculator will do it for you, but it's still quite useful to remember these. Okay, so now, pH. Notice it's a lowercase p and a capital H because it is talking about how much hydrogen ion is in a solution. pH is defined as the negative log of the H3O plus concentration. However, most people just say the negative log of the H plus because the hydronium ion and the H plus are basically interchangeable. Now what this means is the concentration of hydronium ion is equal to 10 to the negative pH, lowercase p, capital H. There is also something called pOH, which is the negative log of the OH minus concentration, such that the hydroxide ion concentration is equal to 10 to the negative pOH. Now, it turns out in the real world, we don't use pOH very often. We talk about pH a lot, okay? But we will be doing calculations based on this. They are related to each other. The pH plus the pOH will add up and equal 14 at 25 degrees Celsius, and all of this stuff we're doing is at 25 degrees Celsius. Okay? So now, let's see if we can derive this. It's kind of a fun exercise to see if you actually learned anything in Algebra 2 about logarithms. We know from the previous gauge that Kw is equal to the H3O plus times the OH minus, and that value is 1.00 times 10 to the negative 14th. Now, I'm going to take the negative log of both sides. So the negative log of the H3O plus times OH minus is equal to the negative log of 1.00 times 10 to the negative 14th. Now, I know that equals 14. Now, this is a product. So using this idea from up here that the log of AB is equal to log A plus log of B, I'm going to say the negative log of the H3O plus the negative log of the OH minus is what equals 14. And that is the definition of pH. And this is the definition of POH. So pH plus POH add together to be 14. All right, we're going to do some more with this on the next page. Thanks for tuning in.